Going live. All right. Just for the sake of people not being here, this is up on YouTube. I don't know if the YouTube channel posted on this campus page. If someone reminds me, I can post it there. Are we probably going to miss school because of the COVID-19 thing? Probably. Just because there's like I think 7 or 8 documented cases in San Diego right now, and when there's 7 or 8, what happens? It's going to multiply almost exponentially for a little while, so they'll basically have people kind of hibernate in your house. Hi. So if we are missing time in class, I'm going to, on the YouTube channel, I will do some recorded crap that we're supposed to cover in class so that you won't technically miss stuff. And also we'll have you some assignments to do on Canvas. I don't know. I've never had to do it before. But every time we do a test or something in here, like we might have one next week if by accident. Anyway, if we do, it's on Canvas. And so the goal is, I don't like people having to take tests by themselves. I think that's stupid. The world doesn't have you do tests by yourself. And so the hard part is collaboration. And there's a lot of neat tools that you guys have figured out with collaboration with Canvas. And you can get together in a Google Docs. I love the methods that a lot of you turned in on the Google Docs. It's awesome. And I like it when it says 100% the same as somebody else. Because that means you didn't work together, and that's great. There's a few people that turned in stuff that was like 25%, and they tried to rewrite it themselves. Why do you not want to rewrite the methods yourself? It makes it harder. It makes it harder, not just harder for you to do, but what is the biggest problem with research? You. The biggest problem in research is instrumental error. Instrumental error is you. The biggest problem with with the experiment with the driving car was we didn't give people enough time to train. So I went back and I redid all the math and I redid all the calculations and I went back and checked everything out. And if you haven't looked at this on Canvas, so I'm going to pull this up here for you. Next week, you're going to have your first, quote, paper due. Paper. Is the background already done for you? The annotated bibliography part? Yes, that's all done and shared. If you have no idea what I'm talking about, talk to other people in the class or bug me. Okay? I will send you a link to the shared document if you're not a part of that. The methods is already done. Okay? Okay, so it's right up here. Hold on. Okay, first experiment write-up. Okay. C shared document. Methods, C shared document. Okay, I forgot to put a link up here before that. Here are the results page. These are all the results that you need. So could you just copy and paste this document into your document? Yes. Okay, so I want to go through this really quickly, just to explain it, and we're going to go through some more stuff. Okay, so tested 6 male, 11 female subjects at Queen Mecca College with an average age of 23.64, standard deviation 4.9. Boring, perfect. Most students reported texting and driving, but there were no significant correlations between rating of their texting and driving and their level of distraction. So I ran a correlation, got nothing. Okay. To test the effects of learning, paired sample t-tests were run on each lap time. There were no differences between different lap times. While students did improve, the differences were not statistically significant. So I went back and reanalyzed the data, and there's a couple zeros in the data that I didn't notice that I ran before. So here are the official results. Is there a significant difference between distracted and non-distracted? How do I know what a statistically significant difference is? Okay. Hi. You okay? Good. Good. Okay, wait. Wait for it. Okay. So how do I know what a statistically significant difference is? When what's under 0.5? It's called the SIG column. Okay? In SPSS, we have a column called significance. What we're doing is when we're running a statistical test, we are comparing if the population from group 1 is the same as the population from group 2. This is a hypothetical situation. If you haven't done this in stats, we'll talk more about this later on. But you set up a hypothesis that my two samples are the same. Then you test, what's the probability that this is true? That's what we test, the probability this is true. If we test this, and this one right here, the probability that's true is 71%. So between lap 2 and lap 4, it's a 71% chance that they're the same. Does that mean they're exactly the same? No, but is it likely that they're the same? 71% likely. So we have to get down to a number of probability is less than 0.05. If we get to a probability of less than 0.05, we say the differences are statistically different. The reason why we probably didn't find statistically significant differences is because of our small sample size. When you find something of 0.08, the difference between lap times was 13.94 seconds. 13 seconds. Distracted versus non-distracted. That's not too bad, right? But some people were extremely slow, some people were extremely fast, so 13 seconds is not likely to, it is likely to occur by chance. But the number is not 0.05, but 0.07. So there's 93% chance that those are the same. Or sorry, there's a 7% chance that these are the same. 7% is a lot better than 71%. But what do we need to get to statistical significance? 0.05. Whenever you see something that is really close, always say more subjects are needed, especially because how many subjects do we have in the analysis? 16. And I deleted the columns to try to make it fit on the page. That's N. Okay? So I made a graph. Let me close that. So I made a graph of what the distracted versus no distracted look like. And this number represents, sorry, I broke the button so it doesn't work most of the time. Why do these things cost $70 and they're like made out of very thin plastic that breaks the second you look at them? It's the bamboo. The Apple Pen is amazing. It's super robust, super strong, doesn't work at all on my computer. Okay. So the average for the non-distracted driving time. So as opposed to looking at the average between time 1 and time 2, I added the time 1 and time 2 together. As opposed to averaging it, I added the times together. The reason I did that was because to give us a larger N, by giving us a larger number of seconds to work with, the variability, if it's really there, will show up. We can talk about that later in the semester when we talk about results, because it's called aggregating data to try to see what's really there. And it's a whole art form. It's actually very fun. Okay, it's not fun. It's boring. But I love it. Okay. So my mean for 2 laps is 190 seconds. Okay, my mean for distracted 2 laps is 180 seconds. What is the actual difference between the two? 13 point, we just showed you that on the previous graph. 13 point something. Okay, so that kind of looks like they're actually different, but what do these error bars represent? 95% of the people who are in this group are like that. 95% of the scores are represented by this thing called the error bar. 95% confidence interval. And this is 95% confidence interval. So what percentage of these overlap? a lot. No, not 100%. So this is actually what the computer is calculating. What percent is overlapping of each other? Is the amount that is overlapping greater than the amount that sticks out on either side? And the answer is almost. No, it's not. If it was less than 0.05, which I have one down below, which I'll show you, they don't overlap. But if it's greater than 0.05, which is on the other slide, so in stats, we were talking about things called proportionate reduction in error. If I know which group you're in, could I make a guess of what time you were likely to have? If I know what group you're in, could I guess what time you're likely to have? Well, sort of. I'd only be right this percentage of times, and I'd only be right this percentage of the times. The rest of them, I'd be wrong, because I can't tell the difference between all of these people. They're all the same value. So if I close this, and I scroll down a little bit, I also ran a bunch of t-tests for males and females. I also ran a test for males and females. Now, we only have 6 males, so there's a lot of variability due to the low sample size, but we have stats. We can take care of this. So here's my dependent variable. Can't draw on this. Oh, maybe I can, actually. Can I draw on this? Microsoft does allow you to draw on things. Aha, I can. Okay, got it. Okay, so here's my lap 1. Are males and females different on lap 1? Okay, is this the... Yep. Not at all. 97% likely to be the same. 45 likely to be the same. 65 off track, they're about the same. Off track 2, they're about the same. Holy moly, look at lap 3. What do we see? Is this mountain or is this a prayer temple? No, this is mountain. Okay. So what do we see? They're not the same. So I have to make a graph to show how they're not the same. So all of a sudden I highlighted this blue. You would say, going back to the top, that was cool to think. When looking at male and female students, there was a significant difference in lap times on lap 3. T at 15 degrees of freedom equals 2.38. P is less than 0.05. I got that from the chart. T is 2.38, 15 degrees of freedom. P is less than 0.05. Again, if you haven't done that before, you're going to get better at it by the time you have to write yours. Just saying. So what this is telling me that it's like this little statement is saying like, well, I'm tall. Does that tell you how tall I am? No. So how do I know how tall someone is? You have a meter stick. I've got little finger measurements that we're going to do today. Okay? And so I measure it. And this is the measured difference. It's called a t-test. Independent sample t-test. What's the other independent sample t-test that we ran? Wait, should I talk about off-track number 3? Is it different? 2.26? Not less than 0.05. We don't care. What about 0.02? I did color it blue so you could see it. And so I write on the second one, and lap 4. T at 15 degrees of freedom equals 2.56. P is less than 0.05. And then I wrote, this finding needs to be validated based on adding more subjects. It's just a slowly... Where the flashbacks. It's okay. No, but again, this is something that we assume... when you go to state or you go to University X, they expect you to do this. Automatically, they're not going to help you. And this is why I'm really pushing my stats students to make sure, like in stats today, or Wednesday, we looked at body parts. And we're going to kind of do that, a variation of that experiment today. And when we looked at body parts, a bunch of data was bad. I added it. It was bad on purpose. And the reason is the students have to be able to look at the data to know, if I have a 0 length leg, does that mean I have a foot attached to my hip? Or does it mean someone forgot to enter the data? But if I add a 0 to the mean, what happens to the mean? It changes dramatically. It pulls the mean down. It skews the data one way or the other. So in statistics, you have to look at the data, make histograms, make pie charts to look. That's why the first thing that we did in this class is what Kenny's dissertation data, right? With Kenny's dissertation data, the first thing that you have to do is you look at the data before you do any analysis. Because we find out that only 6 people are burnt out, you don't need to do any more analysis. Because you don't have enough people who are burnt out. But we found significant differences with only 6 subjects. So what should we do? Get more subjects. If we add more subjects, and if we find differences with 6 students, if we add 6 more, and the differences go away, what does that tell us? It's not real. Okay, there's a thing called an artifact. Artifacts are things that look like they cause problems. Like, okay, we'll use the COVID-19 right now. There are a couple people in San Diego have tested positive, and then they tested them again, and they tested negative, and then they tested negative again. Yay! And they sent them on their way. They came back with flu-like symptoms, and they tested positive again. Instrumental error. Oops. The test kits that they tested with them the 3rd and 4th time were expired or invalid or... What's the biggest problem with experiments? You. It's the people running the tests. And that's why it's kind of, I feel safer now with Ben's in charge. Okay. Right. Okay, so he wasn't doing anything anyway. Here are the differences in lap time. And now, I don't know how to change the colors of the bars, so I changed the background, which I do know how to change. So I really like the yellow on the pea soup. Very nice. Okay. Which groups did we find significant differences between? I got lots more colors on this. Lap 3 and lap 4. Okay? So, lap 3 is... Oh, it's the color that I turned the background. You can? I can't. Yeah, okay, so it's up here somewhere. It's in that box somewhere. I didn't realize I turned it that color. Okay, we'll just look at lap 4. It's somewhere in there. I don't know. I'm just guessing based on the statistics. It should be in that there somewhere. Okay, lap 3, I didn't realize that I changed the background to lap 3 color. Okay. I don't have the SPSS data file in here, so I can't just remake the graph for you. But you can look at the mean differences anyway. But are these two means different? This is lap 4. How do I know? What percentage of the 2 errors overlap? Not much. So this is less than 0.05. Lap 5, how much overlap? Almost all of it. The only part that doesn't is there's a bunch of down here, but there's also only a little teeny bit up here. And if we look at lap 3, do you think they would overlap? No, not as much as lap 1. So when I start looking at the overlaps, when I start looking at all the overlaps, let me get rid of the things here for you. Okay. When I look at the overlap, the chart itself, what I'm looking at here, I don't know how to make it unzoom, but whatever. Oh, there it is. When I look at this graph up here, I can really see that lap 4 and lap 3, which we can't see on here, those are the only two that are statistically different. So is this really meaningful? What if I connect the dots? Make a line graph. What do you see? It seems to be leveling out. For females, they seem to keep getting faster. Males seem to level out. Maybe there is an ideal time at which we drive around this track. What's the problem with using 5 laps before we start messing with people? Time. It just takes too much time to run the experiment. Okay, so we talk, in order for you to drive, wait, okay, we're going to go there in a second. I want to go through the experimental part first, and then we'll talk about the other part. Okay, I really want to talk about the other part. I'm not going to. Okay, so, because I love doing this stuff. In a real experiment, in a real honest-to-goodness experiment, what do we have? Really important you write this down right away. What do you have? In a real experiment, what do you have? I just wrote the letters up here for you so you can get through this a little faster. Independent variable and a dependent variable. Okay? We are going to be doing what's called a quasi-experiment today. Versus a true, real experiment, we're doing what's called a quasi-experiment. The quasi-experiments are actually much more fun and much easier to administer because you are less involved with making mistakes. Okay, so what is the independent variable in our driving experiment? There are 2 independent variables we've discovered. Okay, good. Distraction. Crashes is a dependent variable. Experience is a control variable. So a control variable is something you have to set up to try to minimize the effect of that control variable on your experiment. What are some other control variables that we ask the people? Yeah, so I'm just going to write Xbox. So it's Xbox experience. And then a few of you had trouble with the Xbox because you just couldn't figure out, not to point at anybody, but you just couldn't figure out how to turn the car with the steering wheel to make the video game car turn. I love watching my son drive the car in his game because he uses the controller, and all of his fingers are working at once to do stuff. Especially like when he's playing Fortnite, he's building stuff, and he's like, and I'm trying to like. So he set me up on the learning mode with it's one finger, my wife typing. Yeah, you're doing like the Wii remote thing, and yeah. Okay, so the control, that's a control variable. Why do we ask those questions? What are we looking for with these control variables? Correlations. If there's a correlation, a relationship between our control variable and our experimental variable, then we can use statistics to pull that effect out. It's called proportionate reduction in error. That's what we're doing in my batch work right now. Introducing them to it. We're not actually doing it. Yeah. Okay. Well, we're looking for correlations. And I also put male and femaleness in there. And texting. Good morning. Okay, so now, so these correlations and these control variables are things that we're really trying to help us, trying to remove. Is there anything that we should have controlled that we didn't? Can you think of anything that we should add to this experiment that we didn't control? All right. We need to figure out a way to make it so we can run subjects a little bit faster. Okay? And not quite so labor intensive. Okay. So, how many levels of distraction are there? Okay, so in any independent variable has levels. How many levels of distraction were there? So there's one level which is baseline, and the second level which is not texting, but text reading. You're reading text messages. So those are the two levels of distraction that we have. Now I'm going to start coughing. Thanks. Okay. Those are the two levels of distraction. Okay, so in my experiment, I'm going to roll down here. When something is between subjects, what does that mean? Okay. Between subjects, two different groups. So between subjects, in our experiment, we have males and females. How come we didn't do between subjects with the texting and no texting? Time. Yeah, so within subjects, smaller sample size, you have a smaller sample size, it's the same people, test, manipulate, and then test again. So for the example, the within subject example that I like to keep referring to is the jars. The jars. I show you the jars, I tell you how much they weigh, and then what do? You pick them up, you guess how much they weigh, then I have you close your eyes and pick up the jars and see how much you think that they weigh. And then what is the manipulation? Eyes open or closed. What's a problem with test, manipulate, test? We call it A, B, A design. Method A, method B, back to method A again. Yeah, so the effect of A on B. So the way we test the effect of A on B, okay, I'm going to back up because I like going too fast. So if I pick up the jars first and I get an idea of their size by the way that they feel, could that affect how I judge them when I pick them up the second time? Yes. So maybe I should have you do a reversal. Pick them up blindfolded, then judge their weight. So that way I get rid of the effect of A on B, and now I have an effect of B on A. This is when you get further on in your research career, this is called counterbalancing. And maybe we could counterbalance our within subjects design. Did everybody do the same thing in the driving experiment? Yes. Except for Tanya, she was struggling, we didn't make her read text. Sorry. She's the only one. Okay, so we did not counterbalance this experiment. So how could, because we're doing it within subjects design, how could I test the effect? Okay, so what did we show the effect of more than anything in this experiment? Not that much, but we saw that their times went down over time. So what could we do? What could we do to change to see if that is true with your texting? There's 1, there's 2, there's 3, and there's 4 and 5. Yeah, so maybe we distract them on laps 1 and 2. Hypothetically, what might we see? Maybe if you're trying to text while you're learning, maybe text while you're learning, maybe that is the factor that we need to do. So you guys, if you're the people that want to use the driving simulator thing, Xbox, to do their experiment, maybe you could distract them while you're training them. And we've got a better distracted method based on the cognitive class. Okay? So, but again, then you could look at the difference of this class between subjects. You could look at the difference of the way that we did it, 1, 2, 3, 4, 5, distracted, 1, 2, no distracted. Then you do distracted, 1, 2, and then measure 3, 4, and 5. Right, and so yeah, so maybe if, and again, we're gonna go through the reasons why, because we're gonna work on a discussion. Yeah, but maybe that. So what we want to do is, Derek said it perfectly. It's what is the effect of A on B? What's the effect of my distraction on learning, or does learning supersede distraction, or when you're learning, do you not pay attention to distractions as much? There's a lot of questions, yeah. It opens up this whole panoply of awesomeness that you can start testing. No, it's great. Okay. Everything opens up to more variables. And that's why trying to come up with an idea and a hypothesis is so important. So on the 20th, if we're still on campus, Jordan Andre, who's tall and fit and cool, is coming in and he's going to show us how to do a library research properly. The way I do library research is not the most proper. I just get random ideas in my head and start Googling crap and then find references from the random ideas that I Google and search for those references and read their references and find more references. It works great, except trying to explain it and teach it to other people? No. That's like teaching someone how to ride a trials bike for the first time ever riding a bicycle. No. And can you look at Wikipedia to start research? Yes. It's a wonderful place to start because every moron posts what they think there. But every so often, somebody posts a reference. And a lot of times a reference is a newspaper article. So we did this with a National Enquirer article. The reason why California has so many earthquakes is because the average weight of a person in the Midwest is gaining weight. So the entire United States is tilting because the Midwest is being weighted down by all the fat people and causing San Francisco to raise up, which is causing the earthquakes. It's brilliant. No, of course not. Yes. And some poor guy blew himself up in a rocket trying to prove that it was flat because he wanted to launch himself into space to see it actually flat for himself, and didn't really do a lot of testing on his rocket before he did it. Yes, it was a conspiracy theory against Area 51, and I'm glad I'm on YouTube saying this. Now, so, I feel bad for the gentleman because it was really cool to build your own rocket, but, okay. I'll stick with bicycles. Break bones, not kill itself, yeah. We will probably do survey quasi-experiments if we don't. And so if the school does shut down for a while because of the COVID, my wife's school, if they have a contingency plan set up, my Southwestern, I was talking to my friend who's a dean, they have a contingency plan set up, and somebody at T-Mobile was sick, going back and forth here in Orange County. Yeah. Or Verizon, I'm okay. But, yeah. But anyway, so it's going to spread, and it's not unless you have a serious health condition, it's fine, and your little people are fine. Most of the people are saying that little people are just disease vectors at this point. They're not really affected by this virus. So your little people just spread it. Yeah. Anyway, so I'm picking my nose now. Okay. Don't touch your face. Okay. But so if it does close down, that's why we're talking about quasi-experiments today, is that you can set up experiments to do online where it's sort of an experiment, but what's the difference between what we did and just asking a survey? Are we actually manipulating variables? Yes. So a real experiment is where the experimenters themselves are actually manipulating the variables. And if you do have a group of people that are testing, it's kind of nice to have one person in charge of the clipboard. Clipboard's really important. It goes with the lab coat and doing science. But the clipboard has exactly which research group the subject is in. So as the person sitting down running the computer, should you know which condition that they're in? Or should you tell the subjects what condition that they're in? No, you have to run experiments blind. You cause the biggest problem in experiments. So, and this is why, I'm a huge problem with coming to doing experiments, because what did I start to do to Ivan, and I started, who else did I mess with in this? The other person I started messing with. I started sending, Brian, the info student. I started sending him more and more complicated text messages. Because I wanted to push the envelope of how distracted I could get them. And to see the capacity of the short-term memory, because that could be the factor that causes them to lose attention, is the capacity of the short-term memory. Okay. So, but by me trying to think about the experiment as I'm doing the experiment, does that screw crap up? Yes. What are the research assistants supposed to do? Follow the protocol to the letter. The researcher is the one administering the research, but the research assistants are the one actually talking to the subjects, because you don't want me to be sitting there manipulating the situation to see how far it can go, because that's what Zimbardo calls it, the prison experiment. Okay, so let's not go there. So I'm going to use counterbalancing as an example. Within subjects are very good. Okay? Within subjects are very good. It's better to test one person multiple times. Once you have them as a research subject, you can get a lot of data out of a single person. The problem is if you have one person who's not a great driver on the Xbox, okay, so if you have one person who's not a great, there's other people just as bad, just saying, but I'm just picking on you because it's fun. But if, you know Anne, okay, but if you have one person that's bad and they do multiple conditions, what happens? Their badness cascades across all the conditions. So a between subjects experiment would be great, except we just multiply the amount of time it takes to do this by 2 or 3, depending on how many manipulations you have in your experiment. We don't have a lot of time to do experiments. I have 100 students that are just waiting to do experiments. 100 students waiting to do experiments. 3 subjects. Okay, and so the easiest way to do it is not actually do a real experiment, but to do a quasi-experiment. And the one we're going to do here in a few minutes is pretty simple. So I want to show you, we did this experiment with the jars. If you weren't here last time, I have jars in my office. Okay, mason jars. Oh, come on, I can see if I can get them all the same. Yes. Oh well. Okay, so I have mason jars. I could find a picture of mason jar and copy and paste it in there, whatever, but I won't. So now, each one weighs a particular amount of clay in them. So the big jar I weighed, and it weighs about 450, 420 grams. So I set 2 of the little ones to weigh exactly the same. I used a chunk of fishing weight in each one so that you can't really tell how heavy it is by the amount of clay. This one is actually full of clay. One of the middle-sized ones is full of clay, but there's no fishing weight in it. So it looks like it's full, but it actually weighs less than one of the other ones. Okay, so I have a couple we call obfuscations. I have a couple different variables in here. So I have you pick up a known lump of clay. And I tell you this is 400 grams. That's the setup. Okay? Everybody gets that first. I give you a known mass. Here, feel this. This is 400 grams. Then I have you pick up each jar. So this is A, B. Hold on, let's take a while. Okay, C and D. Okay? I did have one extra jar in there, but this is simple enough. So if I were to truly counterbalance this, subject number 1, okay, they're going to pick them up twice. Each subject's going to pick the jars up twice. Within subject's variable is eyes open or closed. So which order should subject number 1 pick up the jars? Well, no, well, open or closed, it doesn't really matter because each person's going to do both. So let's just have the first person go A, B, C, D. Should they pick them up in the same order with their eyes closed? What would happen if they picked them up in the same order with their eyes closed? Sensory memory. They would feel them as the same weight if you picked them up in the same order each time. So the second group, where you would go C, D, B, A. So what about subject number 2? If you have the subject number 2 pick them up in the same order that subject number 1 picked them up in, you are measuring the perception, the effect of A on B. Sure. And then this one, we could go A, D, B, C. So what do you have to do for every single subject? Called randomized counterbalancing. So, I love this story. I wish I could remember the girl's name that did this because I could throw everything back, but I can't remember her name. She did have a really cool yellow Honda Prelude with the 4-wheel steering. No derivatives those cars, but they were really cool. Okay, so we were doing this experiment using a potentiometer, measuring muscle recruitment, and seeing what the physiological causes of the size-weight illusion were. It was really fun to figure out and set up. The professor that I was working for, he goes, why don't you guys do this as a project? This is my senior year at San Diego State. We got a bunch of subjects to run. It was really fun. It was really fun. We didn't do it for any class or anything. We just did it to learn how to do experiments and both put resume stuff. So she did this for her counterbalancing. A, B, C, D. Group 4 is B, C, D, A. Group 5 would be C, D, A, B. Can someone see a problem? Back from 0. They're all in the same order. She just started it from a different letter. And so we finished running subjects, and I'm looking at the data analysis, and I'm like, you didn't counterbalance them. She goes, yeah, I did. She didn't understand that that wasn't counterbalancing. Because she was, every time you picked up B, what was in front of it? A. Every time you picked up C, what was in front of it? B. Except once every fourth time where it was the first one. And then, so what happened with our ability to find differences that were truly caused by the size-weight illusion? It lessened. Okay, we still found significant differences because it turns out this illusion's strong enough and the order effects aren't affected by counterbalancing. The small one still feels heavier regardless. Just saying. Okay. But, and this is my favorite part. So she was supposed to do the literature search. That's what Jordan's going to come and talk to you guys on how to do properly. She only looked at research published within the last 5 years. Because in every class, they tell you only use sources from the last 5 years. Right? So I went back to do literature search because after her counterbalancing fiasco, I didn't want trusted that she did a good background research. And guess what I found? The exact same experiment done in 1974. Every variable that we figured out and came up with and really worked hard to sort out and figure out and suffered, word for word, except they used paint buckets. You know, paint cans. We use bottles. So wait, so did we just completely waste our time? Yeah, can we publish this? No. No, not plagiarism. You can publish research that replicates old research if it adds something new to the literature. If you found exactly the same thing that they had found in this article in 1974, well, if I just copy and paste it and change their names, that's bad. So we basically found the exact same research, which I was extremely happy by because we came up with this all by ourselves. I was 4 then. I didn't read the research paper that we initially read. So this was really cool because we came up to the same conclusion that they came up with, which is great, which validates the research and validates the explanation. Yay, everything's cool. Comma. We don't get a publication out of it. She turned it into publication in the Journal of Sensation and Perception without my or Dr. Kobus' name on it. Oops. Dr. Kobus comes into my office in my little cubicle space that I worked at, and he goes, did you know that this was submitted? Like, what do you mean? He goes, well, my friend's a journal, is the journal editor, and this was submitted to the Journal of Sensation and Perception. And he goes, did you do this? I'm like, I did the experiment, you were there, but I didn't, it just had her name on it. Yes, I would have been thrown seriously under buses if not, because she got kicked out of school for doing that. Yeah, because she had San Diego State University at the top of it. Did she actually do the research by her? Did she have permission from the Human Use Committee for Protection of Subjects to do the research? No, Dr. Kobus has permission. And so when you have a principal investigator, you work under the principal investigator's credentials and license. As plebes, as young students, you can't publish something unless you have gone through all the credentials. She didn't have any of the credentials, but she's turning it into a known journal to be published for review. And it was very poorly written, too. Luckily, well, I probably did that part, but that's not important. Okay. So it just, please be careful. If you want to publish anything, what do we do? Yeah, well, tell me, and Dr. Salazar, who has all the cool things, will stick her name on it, and then we could submit it. I don't have any of the credentials to submit my own research, but Marissa does, aka Dr. Salazar. Okay, so let's talk about a quasi experiment again. I like how things get generally bigger as we go down the page. It's cool. Okay, let me take this over here. Oops. Totally not worth it at this point, but I'm going to do it anyway. For those people that are writing down the page, weirdness. Okay. So what do I mean by a quasi-experiment? Well, you do. I started writing our not manipulation. It's not good English. You are not manipulating independent variable. So this takes a control variable away from you. Okay, so we'll take a break here in about 5 minutes, and then we'll set you up with the experiment. But what we want to do is we use measured independent variables, not manipulated. Measured independent variable. What's the easiest independent variable that we can measure in class? We're going to measure your finger. Oh yeah. But that's a dependent variable. Does blank predict ratio, not rations. No finger rations, please. I'm sorry, you're over your number of fingers you're allowed this week. Yeah, we're okay. Finger ratios. We're going to measure finger ratios. I've got pieces of paper. Okay, y'all got fingers? Almost all of them, yeah. We'll only be measuring 3. Those, okay? And so, one of my students had missing, so he measured the nub. Just like, put it on there. Well, that's my finger. Like, well, is that normal? No. All right, I chopped it off. Why? Got a caught in the rope. No, the rope did it for him. Yeah. A good friend of ours actually got his hand caught in a rope sailing, flipped and popped his finger off. He's on his first date with this new girl that he was trying to date, and she happened to be a retired registered nurse. So in her infinite awesomeness, she jumped and snagged the finger before it fell in the ocean. She immediately, she goes, I whipped off my blouse, and realizing that I'm a 55-year-old woman, probably not the best choice, but she dipped it in the cooler and wrapped it in her shirt around his missed finger to keep it damp but not icy, and we sewed it back on. It worked.
Yeah, did they work out though?
Yes, they were still together at Christmas, and this happened back in November, so... yeah, I think she should. I think his wife died from cancer, so I don't know if he's quite ready to be married again, but okay. Yeah, that was a good catch. It's just literally and figuratively. But the fact that, all of a sudden it's like, snap, ow! And she's like, whoosh, ninja skill, grab the finger. Ew! Oh no, ew! Yeah. Good story though. Okay. Yeah, it's fine. You can do fine with the other one. Okay. But yeah, he said the nerves don't connect yet. Yeah, it doesn't quite move yet, but you have to, you move ice around on it, and you move it as you put ice around on it, and whatever the sensory feedback goes, it goes to the nerve, and your brain goes, okay, now that nerve is there, okay, got it. That nerve is here, okay, got it. And it'll take about 3 or 4 months, and it'll reconnect. Mostly. You'll still have a few dead spots. Okay. Zombie finger. So, the idea of does something predict finger ratios? Okay, so we're going to be measuring 2 variables about you that we're not going to manipulate. It'd be entertaining to manipulate, but we're not going to. We're going to look at biological sex. Okay, no manipulating your biological sex in class. Okay? And so we're going to ask you, do you have male or female reproductive anatomy? Why are we asking about your reproductive anatomy? That's what biological sex means. We're not going to ask you any more about your reproductive anatomy than that. Which one is it identified as? Okay. So the second one, we're going to be measuring your masculinity and femininity. So masculinity and femininity are social constructs, not biological constructs. And this is where the quasi-experiment comes in. So the reason why it's called a quasi-experiment is we're going to be looking at male and female. That's a variable that in 90% of the population is identifiable and quantifiable. So if I ask my students, what do you identify as, male or female? They can choose male or female, or they can choose option number 3, which is pan-gender or gender neutral. I like the word queer because my friend's son, Shelby, is transsexual, has got removed his breasts, but still has a vagina, but doesn't ovulate anymore because he's taking testosterone. His partner is also a female to male transsexual who just got a job at Disneyland. Yeah, big time. He's a costume designer, and so he got hired at Disney. Yeah, that's huge. It's really cool. It's like living the dream. Anyway, but they're a couple. So what are they? They're trans gay. Or we just use the word queer. It's so much easier. Because it's trying to, you get my buddy Jim is like, he's like old school man, and the big joke is he's like, I need a whole Venn diagram to really explain it to anybody. But they're happy. He doesn't know what he's going to do though. Is he going to move to Anaheim, or is he going to finish state? Should he go to Cal State LA? Moving on. Okay. So masculinity versus femininity. How do we measure masculinity versus femininity? I sent out a survey for those people on their phones right at 9:05. Okay, and I sent out the survey. I sent it out yesterday afternoon, but there's a survey link on here, which for some reason I'm going to edit and make it so it actually goes live. No, this isn't what kind of dog you are. I love that one. Yeah, Stats is the really fluffy dog. Okay? So we're going to measure our fingers first. Okay? And then enter the scores from the following survey. Ooh, I forgot to add something to this survey. Hold on. Let me edit the survey real quick before anybody fills it out. The one on ours is class is yes, and the other one is a Pomsky. It's the Pomeranian. No, it's shit rain. It's a Pomeranian Shih Tzu mix. Don't call it a shit rain. It's just not nice, but it's better than whatever it is. Yeah, it's a Pomeranian. Anyway, our neighbors have one. It's named Luna, and it's extremely cute. When it was a puppy, it looked just like that. It was like a little bizarre. It's psychotic though. It's a little bit inbred. Okay, where'd that question go? Okay. A little criticism. Okay. Luckily, I'm impervious. Female, male, prefer not to say. Okay. So I'm going to put that one's up there now. So if I hit refresh, there we go. Is making Google Forms easy? Yes, and it's really awesome how it quantifies and you can get data almost instantly from a very quick Google form. Okay, what kind of variable is this identified biological sex? Well, it's a quasi-independent variable, and what kind of variable is it though? Is it a scale? Categorical, okay? It's unless you have, if you have a dichotomous variable, you can use correlations with it, but if it's a free choice, you cannot use correlations because a category doesn't represent quantity of something. Unless you write like testicles as a quantity of, then, no, that's what doesn't work. Okay, so these variables are they nominal, are they categorical, are they scale? What are they? Continuous. These are continuous variables. Now, there is a restriction of range. We don't have anybody in here with Klinefelter syndrome that I have noticed. If you ever work with children with developmental disabilities, there's a disorder called Klinefelter syndrome. It's a person has an XXY. They have an extra sex chromosome. They have really long fingers. Very, very, very large foreheads and very long fingers. And I worked with the Special Olympics for a bunch of years. I taught teaching kids how to shot put. And the Klinefelter kids had a really hard time shot putting because very thin fingers. And you're trying to throw a shot put, so we taped their fingers together so that they could throw the shot put without hurting their fingers. One of them did not like it, the other one thought it was pretty cool. Anyway, so you're going to be measuring these in millimeters. The easiest way to measure it, I will show you how to measure it in a few minutes. The easiest way to measure it is use a pencil and make a mark on the ruler, take your hand away, and then read the measurement, and then you type it in. But because you are the biggest problem doing experiments, please don't type millimeters after each one. No. Don't type mm after it. You're measuring everything in millimeters, but if you type mm after it, how does the computer see the data? As text. If there's any letters in there, it'll see it as a text field. You can't do math with words. What are words for? When no one listens anymore. Words. Sorry, I'm playing that really sweet. Okay, so when you go to this gender test, okay, I'm opting in for my cookies. I'm opting out of downloading Download Manager. Okay, this is a really cool test. If you like these, you click on tests. Some of you might want to use this for your research methods project. Coronis anxiety type of mental health phenomenon. I did this one. I understand. I'm a combination of Winnie the Pooh and Tigger. It totally does! I am totally hip. I'm a little more Pooh than Tigger, but that's okay. Yes, but internally I might be a little bit more Pooh. Okay. Anyway, but again, these are awesome. Okay, there's a whole bunch of these, and so you can have a gender orientation, a sexual orientation test, dark core test. The Kinsey's test. This one's actually, yeah. You can do whatever one you want. I want you to do this one first, but big asterisks with these. Okay, these have very good face validity, which means they seem correct. Do they have much construct validity? What does construct validity mean? Okay, so first day of class, what's a construct? An ID that we build using data. Okay, the construct validity of these, like, so I suffer from Winnie the Pooh and Tiggerisms. Okay, the dog personality test, I'm not sure if that's on here. I haven't gone through all of these yet. Psychopathy test, I like it. Homophobia test, faces test, transgender test, black and white test, narcissism test, president test, ironic. Partner test, Star Wars test, Greek loves test, car test? There's gotta be another Star Wars test, a Trump test, politics. Oops, sorry, I don't want that one. I don't know that one. That's a racism test. Transgender, will test, wealth test, climate test. Okay. Ooh. Okay, could I keep going on here? Yeah. And you could go through and take every single one of these, but the construct validity of these might be relatively low. Now, they use references. So these seem to be like they're useful and reputable, but we can't. How do we test this to find out, is this test, especially the one that we're doing in here, which is the masculinity femininity test, which is somewhere in here, gender test, is that the gender test? Gender role test. I think that's the one. Yeah. Yep. Okay. So this one is more, the construct validity of this seems to be okay. And it tests, I've done the Minnesota Multiphasic Personality Inventory, which is a very strong, robust test. Then 700 questions, costs a lot of money to do it, about 4 or 5 hours to take. So, and the results that I did from this came back very similar to my results from the MMPI. So for the test retest, or multiple measures validity, this is actually not too bad. But what makes it work correctly? Answer the questions honestly. Your name is not on the form, okay? Unless the person sitting next to you is pointing and giggling at you the entire time, it should be relatively anonymous, okay? So, and I'll show you my results at the end I'll put my results in up here because I haven't measured my fingers lately. Okay, so, I want to take a break, yeah, and then turn your computers on when you come back, yeah. I can't tell you that because it might change the way you measure your things. This is a hypothetical construct. It was tested a couple years ago. One of my students was a flyer. Anybody know what a flyer is? Cheerleader flyer. Andrea, you would be a great cheerleader flyer. Were you a flyer? Okay, yeah. No, you don't trust people. Okay. So what do they do to the poor flyers in cheerleading? We throw them in the air. As someone who was recruited as being a bass at San Diego State, except I didn't pass the qualifying of dancing, because I don't, but I do pass the qualifier of throwing little people around, and that's highly entertaining to me. So years ago at San Diego State, there was one cheerleader, I think she might actually be a coach now. Her name was Jennifer. They all were named Jennifer back then. Drop dead gorgeous, half Chinese, half Japanese, and half something else. I'd follow her around pretty much all the time. So she goes, why don't you come and like see if you can try out for being a bass? And I was a big shot putter at the time, and I'm like, I can throw people very far. And so a couple times they have like a little net of people, and they put their foot here, and you just go like this, fling, and they jump at the right point, and you can launch them 20 feet in the air. Anybody watch the Cheer show on Netflix? How many flyers did they kill in that show? Yeah, one dislocated her elbow, one broke 2 ribs, and not from crashing, the dislocated elbow was crashing, but from just catching. Just catching, nobody actually died, but I thought the girl was going to die that they threw and missed. Like they had this thing they're supposed to throw them off to the sides, and that whole base on this side was just not there. You hear this, ah! My son actually rebounded a few times. Did that happen to you? Okay, yeah. So, yeah. Well, Katie, one of my students, she was at San Diego State. She was a flyer for San Diego State, and she goes, we were doing this experiment. We were measuring male and female fingers in my class because we have this data set, and she goes, well, that's interesting. I want to see if the flyers are more masculine. Because it takes, apologizing, but it takes balls to do that. You need to have that attitude, yes. Okay? You need to have that attitude like, oh, bring it on, let's see what I can do in order to do that. She goes, well, those people obviously are much higher testosterone females if they're likely to want to be thrown around. And most of them aren't little tiny svelte people, they're actually, like you have muscles on your shoulders. And then the reason you have muscles on your shoulders is if the people that don't can't hold the postures. So she was saying that those are higher testosterone females. Well, maybe that's what that's measuring. So she surveyed all of the cheerleaders on campus. She took a picture of their hand, against a piece of graph paper, and then used the graph paper to line it up on a computer screen, and then just measured on the computer screen all of their fingers. It only took a few minutes to take pictures of them with the entire cheer squad's hands. Then she went around San Diego State and took pictures of people's hands on the piece of graph paper just randomly around state. So she had a comparison group of cheerleaders versus non-cheerleaders and measured all their fingers. Well, let's find out. Okay, so we'll go take a little break. When you come back, we're going to measure this and put it in. Okay? I will show you how to measure your fingers when you guys get back. So you can come up and grab a ruler. And now I'm going to stop the recording so that I don't have idle chit-chat